Okay, so let's say we are given a problem. A solid steel bar, 40 millimeter diameter, 2 meters long, passes centrally through a copper tube of internal diameter 40 millimeter, thickness of metal 5 millimeter, and length 2 meters. Okay, the ends of the compound, the ends of the bar and tube are braced together. Okay, the ends of the bar and tube are braced together, and a tensile load of 150 kilonewtons is applied axially uh, on the compound bar. Question says find the stresses induced in the steel and copper. Okay, so let's try to represent the information on the diagram. We have that a solid steel bar, 40 millimeter in diameter, okay, 2 meters long, is okay, passes centrally. First of all, let this be our steel bar. Okay, this is our steel. Diameter of the steel is 40 millimeter. Okay, 40 millimeter. Okay, we are trying to represent the information on the diagram. And okay, see, it passes centrally through a copper tube, so which means there's a copper tube that is outside of it. So we have a copper tube, okay? So you have something like this. So this is a steel bar, steel, while this is a copper, okay? Copper. Because the steel bar is passed centrally in the copper. That's what the information is saying. So passes centrally through a copper of internal diameter. The internal diameter of the copper is the same thing as the diameter of the steel bar. Okay. Meanwhile, they give us the external. Okay, they give us the thickness as 5 millimeter. Okay, so thickness of the copper is 5 millimeter and length is 2 meters. Okay. So length is 2 meters. Thickness of copper let's use C is equal to 5 millimeter. Alright. The first thing we realize is that from compatibility equation, okay, we have that strain of copper must be equal to the strain of steel. That's the first thing we point out. Okay, if strain of copper must be equal to strain of steel, but we recall that strain itself is simply stress all over Young's modulus. Okay, if this is so, then in place of strain of copper, we can simply write stress of copper over Young's modulus of copper, and that's equal to stress of steel over Young's modulus of steel. So let's call this equation 1. From the question, they gave us the Young's modulus of steel. I hope you guys are following.
Yes, sir.
Okay, we are given the Young's modulus of steel and copper and that of steel from the equation, where EC, which is Young's modulus of copper, is this 100 and that of steel is this. So let us present this information into this equation. So that simply means that we have stress of copper all over Young's modulus of copper is 100 by 10 raised to the power 9 giganewtons to be equal to stress of steel. You have stress of steel all over. Young's modulus of steel is 200 giganewtons, so which is 200 by 10 raised to the power 9. Now let's do something. Look, if I cross multiply, this multiplies this. Meanwhile, this multiplies this. But I want to make stress of steel subject to the formula. If I want to make stress of steel subject to the formula, let me just multiply this to this. If this multiplied by stress of copper, I will be left with stress of steel. So that simply means that the stress of steel, sigma s, is simply upon cross multiplication, 200 multiplied by this value divided by this. So you have 200 by 10 raised to the power 9 times stress of copper all over 100 by 10 raised to the power 9. That is clear.
Yes, sir.
Okay. So we have that sigma steel, which is stress of steel, is now, this is saying 200 divided by 100, of course. This This will cancel this. So 200 divided by 100 will give us 2. Yes, it will give us 2. So this is actually 2 times sigma copper. So call this equation 2. Are you guys following?
Yes, sir.
Alright, call that equation 2. So from equation 2 now we obtain that the stress of steel is actually 2 times the stress of what? Copper. Now, from recall I said earlier that load carried, the load carried is actually shared by what? The two materials that makes up the compound bar. And the load was given to us as what? 150 kilonewtons. Okay? And a tensile load of 150 kilonewtons. So it means now that 150 kilonewtons, recall, load carried is actually load of steel plus load of copper. And this load carried was given to us as what? 150 kilonewtons times 10 raised to the power 3 is now equal to the load of steel plus load of copper. That's the second equation. Okay, but recall we said that stress itself or load, if stress is simply load over area, it means now that load, which is P, is actually stress times area. Okay, it means that load is actually stress times area. So therefore, 150 by 10 raised to the power 3 is now equal to the load of steel is simply the stress of steel times what? Area of steel. So you have, in place of load of steel, you have stress of steel, sigma s times area of steel plus the load of copper will give us the stress of copper times area of copper. Are you guys following?
Yes, sir.
Okay. So at this point, we've already obtained, recall from equation 2. From 2, we obtained that stress of steel is what? 2 times stress of copper. So sigma S is actually 2 sigma C. Stress of steel is 2 times stress of copper. So anywhere I see stress of steel in this equation, call this equation 3. Call this equation 3. Anywhere I see stress of steel in this equation, all I need to do is simply what? Plug in this value into this equation. So therefore, from equation 3 we have that 150 by 10 raised to the power 3 is now equal to stress of steel is 2 times stress of copper. So in place of sigma S, I will now have 2 sigma C times area of steel plus sigma C times area of copper. Are you guys following?
Yes, sir.
Okay. So you have, okay, let's call this equation 4. Now at this point, we now obtain the areas of the steel and area of copper. Okay, so recall diameter of steel was given as 40 millimeter. The steel is inside with the diameter of 40 millimeter. So diameter of steel is equal to 40 millimeter. And 40 millimeter is equivalent to what? 0.04 millimeters divided by 1000. Therefore, area of steel, you already know the formula. AS is simply pi diameter square all over 4. Pi diameter of steel square all over 4. So area of steel is equal to pi is 3.142. Diameter of steel is 0.04 all square divided by 4. So this is actually 3.142 multiply 0.04 square
1.6 times 10 to the power minus 3.
minus 3.
Yes, sir.
Okay. Divided by 4. So 3.142 multiplied by that value. Area of steel is equal to
5.0272 times 10 to the power minus 3.
minus 3 divided by 4. So divide the value by 4. You have area of steel to be equal to
1.2568
1.26. Keep it as
times 10 to the power minus 3.
times 10 minus 3 meter square. Okay, so we're able to obtain the area of steel. Now take note, we are given that the copper material has internal diameter of 40 millimeter. Okay, from here the copper tube of internal diameter 40 millimeter and thickness of metal is 5 millimeter. So the thickness of the copper is 5 millimeter. Now, how do we find the value of what the external diameter? Because this steel is actually placed inside the copper. If the steel is placed inside the copper and then the copper has internal diameter, it also means that the copper has external diameter. I hope that's clear. So if you watch, this is the internal diameter of the copper, and this point to this point is what we call thickness, T. This point to this point is also called the thickness of the copper, T. So from this side, this is the thickness of the copper. From here, this is the thickness of the copper. Meanwhile, from this point to this point is actually what the internal diameter of the steel, which is also the internal diameter of the copper, D. So to obtain the external diameter, which is from here to this point, external diameter of the copper, the external diameter of copper is actually, this is how you find external diameter. External diameter of copper G is actually the sum of all the values you have here. T plus D plus T. So T plus T will give us 2T plus D. So that's how we get the external diameter. Whenever the diameter is given to you and the thickness is given to you, to obtain the external diameter, you use the formula. The external diameter is capital G will give you 2 thickness plus internal diameter. This is how you find the external diameter of the copper. Because the copper already has an internal diameter of 40 millimeter. Okay? So this is now equal to 2 times the thickness. Thickness was given as 5 millimeter. So 5 millimeter divided by 1000 to convert to meters. That's 5 by 10 raised to the power minus 3. Plus the internal diameter is 0.04. So external diameter of copper is now equal to 10 by 10 minus 3 plus 0.04. So which means the external diameter of the copper is equal to, please, 10 by 10 is for minus 3, should be 10 is for minus 2. That's 0.01 plus 0.04. Should be 0.05. Do all this for me, should be 0.05.
Yes, 0.05.
So you have 0.05 meters. So this becomes the external diameter of the copper. Okay, so if that's the external diameter of the copper, so to obtain area of copper, I've told you guys that whenever we have any material that has internal and external diameter, the area of copper is simply pi over 4, the external diameter squared minus the internal diameter squared. Okay, so which means area of copper is now equal to pi is 3.142 divided by 4. Okay, so the external diameter is given at 0.05. So you have 0.05 all squared minus, and the internal diameter is 0.04 all squared. So area of copper is simply, please, 3.142 divided by 4. What do you have? Three point one four two divided by 4.
0.7855.
0.7855. Okay. Now 0.05 squared.
2.5 times
minus
10
3
divided by 10.
by 10 is power minus 8 minus 6. 1.6 by 10 power minus 3. So subtract these two values from me. 0.7855 multiplies 2.5 exponential minus 3 minus 1.6 exponential minus 3.
9 times 10 to the minus 4.
This value minus this value.
Yes, sir.
Check it again. 2.5 exponential minus 3 minus 1.6 exponential minus 3. Check it again.
Yes, sir.
What's the value?
9 times 10 to the minus 4.
9 times 10 to the minus 4.
Yes.
So multiply by this value. Which means area of copper is equal to multiply by 0.785.
0.0695 times 10 to the minus
9
5 times 10 to the minus 4.
minus 4 meters. So we obtain the area of the copper and we obtain the area of the steel. We simply substitute that into equation 4, right? Yes, into equation 4. We know the area of the steel now, we know the area of the copper. We substitute the equation 4. Area of copper gives us 1.26 by 10 to the minus 3. So let's do and see. So substitute AS is area of steel and AC is area of copper into equation 4. If you do that, you're going to have from equation 4, you have 150 exponential K equal to 2 sigma C times AS. So 150 by L squared K equals 2 sigma C times area of steel. Area of steel is what?
Area of steel.
1.26 exponential minus 3. So 1.26 by 10 to the minus 3. Okay, plus sigma C times area C, area of copper, which is 7.069 by 10 to the minus 5 by 10 to the minus 4. So 150 by 10 to the 8 is now equal to 2 times 1.26 exponential minus 3. Let's expand this bracket. 2 times 1.26 exponential minus 3.
2.52 times 10 to the power minus 3.
Minus 3 sigma C plus, of course, about 7.0695 by n to the minus 4 sigma. So you see that at this point you can add them together. Because it's a sigma C and it's a sigma C. So they can be added. So you add 2.5 to exponential minus 3 plus 7.068. 7.0695 exponential minus 4. 150 by 10 is now equal. So you can add them.
$3.22695 times 10 to the minus 3.
227 by 10 is what?
Minus 3.
Minus 3 sigma C. So you see that at this point, you can now find the value for stress induced in the copper. You have to divide both sides by what? Dividing. So that's the sigma C is now equal to 150 by 10 raised by 8 divided by 3.227 by 10 is minus 3. So which implies that the stress induced in the copper is equal to what?
46, 48, 28, 01.36.
464828, value?
Yes, 01.
01.36.
336.
Okay, 36. So you cannot calculate this in mega units. So you can simply say 1, 2, 3, 4, 5, 6. So move 6 steps backwards. It implies that sigma C, stress in C is actually 46.48 mega newtons per meter square. So that's the first stress. That's how you find the first stress. Okay. Now recall from equation 2. From equation 2, we obtain that stress induced in the steel is what? 2 times the stress in the copper. And we found the stress in the copper to be that. So what is doing is what? Multiply stress in the copper by 2. That will give us the stress in the steel. Okay. Alright, so we recall from equation 2 that sigma x is 2 sigma c. So that simply implies that sigma s, the stress in the steel, is actually 2 times 46.48 meganewtons per meter square. So that implies that sigma c is what? 2 multiplied by that value should be 90 point something. 92.6. 96 meganewtons per meter square. So that's it. That's the stress induced in the compound, but the stress in the copper rod and the stress in the steel. That's how you find the compatibility equation and end equation. Okay.